Hi everyone. Hi Tia and Professor. My name is Shixin Li and this is my PS8 revision video. So in this video, I will highlight the mistakes I made in the process and why I made it and what parts I was missing, what's the correct answer, how I improve it, and also how can I avoid the similar mistakes in the future. So let's start. Actually, for three questions, for question one and question two, I got some mistakes there, and for question three, I got the full credit. So that's started as from the question one. So in the question one, and so the first part is so first part, I made a major error in proving that pi is not belongs to NP search. So here we need so we have two parts. The first is that we need to prove that the pi belongs to the P search, but the pi is not belongs to the NP search. So for the second part, um one thing we need to make sure that is in order to prove that pi is not belongs to the NP search, it's important that to highlight that because the function is fx equals to n and it's the natural number. So definitely it's true that um any natural numbers should be the possible output, right? And as we know that arbitrarily large natural numbers require arbitrarily many bits to represent. So the output then is not bounded. And of course, so in this, because of this, we cannot make sure that the output can be verified using the polynomial time. So this is the key. This is the problem. So that's the reason that pi is not belongs to the NP search. And the next question is the exponential search reduction. And in this part, the part I'm missing is that I didn't mention the input size of the oracle. So in order to highlight the input size, we know that if the pi reduced to gamma polynomial time, so this means that there will be a reduction. R solving pi runs in polynomial time, which is if C is a constant, the time should be the O n power to C, and also making the O n power to C, which is the polynomial course, to an oracle solving gamma on input of size polynomial, which is O n power to C, right? So this is the input size of the gamma. And the next part is the 3 SAT to flip 4 SAT reduction. And so I make some mistakes here. The first is that I said that the transformation takes the time OM. This is not correct. The correct answer should be the OM plus M. The reason is that I only consider the M clauses, but there are also M plus 1 variables. So when we consider about the transformation time, we not only include the clauses, also we need to take into account of the variables. So the final time will be the O n plus M. And also the second part is I need to elaborate more on the directions from flip 4 SAT to the 3 SAT. So the key here is the resolution, right? Because in this part, if we have a, a valid solution Rx for the flip 4 SAT, right? We need to make sure that Sx is valid for 3 SAT. The resolution guarantee this. And also when we transform flip 4 SAT to 3 SAT, right? So previously from 3 SAT, for each clause, we create two clauses, right? One is with the YK, one is with the negative 1K, YK. And in the opposite, if we have the flip 4 SAT, we can just using the resolution to reduce, not reduce resolve these two clauses into one, which is L0 or L1 or L2. So as you can see, it's right in here. The two sides, one is here and one is here, and the resolution guarantee that both direction, if one side satisfied, or if one side is one, another will be one. If one side is two, if one side is zero, another will be zero. And also we need to show that the output are of polynomial then. Of course, so from this transformation, right? I will highlight if we transform from 3 SAT to flip 4 SAT, right? So for each clause, we will get two. If we have M clause in 3 SAT, we will have two M clauses in flip 4 SAT, right? Because for each clause, we create two more clauses. And also for the variable numbers, we will have two M more variables. The reason is that for each clause, right, we create yk and negative yk, so we have M clauses in total, right? So all of these transformation are polynomial. So they are polynomial, that's of course. And let's go to the last problem, which is the graph recoloring is NP complete. And here, the part I'm missing here, as shown in the note, is how can we convert whatever three coloring output to the overall solution? So let's suppose that we have already, so for the three coloring, there exists a solution, right? And here, in the graph construction process, we have one more variable, which is, as you can see here, is the V occulus, this vertex, and this vertex is always colored as color 3, right? So let's not call it color 3, but just let's call it color ABC, right? So it's always colored as color C. And how can we convert the three coloring output into the overall solution? The key here is that, so as you can see, for each variable xi, we have two more vertices, which is xi and a positive xi and negative xi. So the key here is that if the positive, we need to focus on the color of the positive xi. So for example, if the positive xi is color A, and also in the clause, for each clause, we also had three more vertices for them, right? Which is the similar as we have in the lectures construction. So if the positive xi is color A, we just need to make sure that in the clauses, the color A vertices, the final presentation here, the final evaluation of it is 1. So let's use an example to illustrate this. So, for example, so let me think a little bit. So for example, in order to better to illustrate this, so for example, if the literal is xi, right? If the literal is xi, and then it's connected to the negative xi, which has the color B, right? And which means that the positive xi has the color A. And in this case, because we need to make sure that the literal xi is 1, is true. So in this case, the xi is true, right? Because the positive xi has the color A, and the literal is the literal xi with the color A. So the final evaluation of it is true. So xi is true, which means that xi is 1. So this is the example of it. So at this time point, I think I already correct all the questions, all the mistakes. And in order, I think all in all, in summary, I think I made these mistakes because for some part I just missing. So because this is the proof process, so I always miss some part. For example, in here I didn't mention about what's the conversion from the recoloring to overall solution, and in this part, for example, I didn't highlight what's the, for example, I think this is, I didn't mention the And also here, I didn't mention the input side of work, so I always make some minor mistakes of not mentioning some part of the proof, which didn't make the proof complete. So in the future, in order to avoid this, I will become more careful and become more considerate when proving something, regarding every details, including every details into my proof to make sure my proof should be complete. And I think this is all the things about my revision video. Thank you so much.